This next video is on esters. Esters are derivatives of the carboxylic acid group. However, the main change is that we're removing the hydrogen atom, and once we remove this hydrogen atom, then oxygen is going to want to bond to something else. Therefore, esters also appear in the middle of chains. Let's further expand this, and I'm going to show you right here that you're going to have a carbon double bonding to the O, then the oxygen bonding to the carbon, and then this oxygen bonding to another thing. If we further draw this formula in a line angle form, we have our carbon with our oxygen, and then another oxygen with its bonding arm, and then the bonding arm on this side, which is the same as oxygen and the bonding arm. If you notice, we're going to have an oxygen side and a carbon side. Whatever is bonding to the oxygen is the oxygen side. Here I'm drawing it with yellow. And whatever is on the carbon side is attached to the double bond, and we're going to take this carbon into consideration. Let me be a little bit more clear. Let's say we have the following molecule. This is a carboxylic acid. This is propanoic acid, if you remember from our previous video. If we take away this H, we're going to leave that oxygen bonding to something else. And let's add another carbon chain right here. So, remember, we have an oxygen side and a carbon side. The carbon side is derivative from the carboxylic acid. The ending for esters is O8 in UPOC nomenclature. So, we're going to do the same with the acid. This was propane, but it's propanoic acid. This is going to be propanoate. Propanoate, that comes from having 3 carbons on this side. 1, 2, 3. So carbon side. And we always draw, or we always name the oxygen side first, like a substituent. So this would be 1 carbon attaching to the oxygen. This is methyl propanoate. That's how we name esters. Let me give you other examples. Let's look at this really quickly. I'm going to draw a few exercises. And then we're going to do another one. Remember, these molecules, you can draw them any which way possible. And just as long as you analyze each of them and you understand how they're rotating, there should be no problem. Let's look at this. Another one, and another one. Let's see. So first of all, let's identify our oxygen side. So what do we have attached to the oxygen here? We have this chain of 2 carbons. On the oxygen side in this one, we have a chain of 3 carbons making this shape. We have 1 carbon, and here we have 1 carbon as well for the oxygen side. Now, let's do the carbon side and let's start the naming. So here we have 1, 2, 3, 4. Here we have 1, 2, 1, 2, 3, and here we have 1, 2, 3, 4, 5. So, just to remember, I'm going to draw little numbers right here. 4, 2, 3, 5. So, the carbon side is always the last name of the molecule. So here we have butane, but it's not butane, it's butanoate. Butanoate. And then what's attached on the oxygen side? 2 carbons, it's an alkyl group, ethyl butanoate. On this side, we have carbon side, 2. So that's ethane, ethanoate. And what do we have attached? 3 carbons in this shape, which is the antenna shape, isopropyl ethanoate. On this side, carbon side, propane, propanoate. And then on the oxygen side, 1 single carbon, methyl. Here we have 5, pentane, so it's pentanoate. And then methyl on the oxygen side, methyl pentanoate. So remember, the names are always oxygen side and then carbon side with the O8 ending.